Quick presentation of our Pyrograph software and how it can be used to simulate your tempering process. So once you have created your account, we will approve it and then you have access to the software. So pyrograph.com, you log in using your username and password and you get to this page. So it's simple. You fill the cells and select from top down, and then we'll move through the tabs from left to right. The first three cells are optional, just for you to enter some info and keep track of what simulation is what. Then we get to mode. So for this example, we'll choose tempering. The oven, when we approve your account, we will we will include the oven you have on your shop floor, so you don't have to go through that complete list. But for this example, I'll choose the 208. Then part, so we select our part. So for the most common parts, it's visual, and we have some other options down below. So for this example, I'll choose a CV joint. Unit systems, you can choose metric or imperial. And the alloy, we have the different alloy. If the alloy you're working with is not there, just tell us and we'll make sure to add it. So then we enter the part dimension. So I'll 1 3/8 for the shaft diameter. The length, I'll put 8 inch. The bell diameter, I'll put 4 inch. The weight, let's say 2 pound. Then loading, so we have two choices, bulk or random, which is like parts falling on the belt from a hopper, from a forming machine, part that just fall randomly on the belt like nuts and bolts or small springs. And then organized, aligned is when we want to control the positioning of the part on the belt for robotic or automated loading unloading, or for part size and shape that makes it impractical to have them just fall randomly on the belt. So for this example, I'll use the organized or aligned loading. Parts per hour, let's say 240. Initial hardness, so there's the hardness that is usual hardness for the material you selected, and then but you can edit that cell. You can put the hardness that you get after hardening. There's no problem. And then desired part hardness is the hardness that we are shooting for after the tempering. So we hit next. So as I selected organized aligned here, this tab was added. So here we choose the part orientation, or how we want it to be positioned on the belt. Then we can add some spacing in between or change the center to center. So as you wish, any will work. So let's say we want for loading purposes, we want 1/4 inch space between each part. And we hit next. So here we have the simulation. So the software determined that I need a surface temperature, or a part temperature around 334 to have my 61 Rockwell after tempering. It chose a time of 20 minutes, 75 to have my 240 pieces per hour. And then it found the temperature, the zone temperature for the part to heat up quickly and then slowly land on the proper temperature. So we have our hardness curve here and our final hardness. Lines are pretty close, but you can see we have the surface and core, so they are steel is conductive enough that there's not much difference between the surface and core when heating with convection. So we have other data like pounds per hour and how many percent of the power we're using, so we can see how much we're using that oven in terms of heating power. So we have that in percent and in kilowatts. So we can still edit these values. So if I want like 300 pieces per hour, then you see it will, we can slow down the belt and the temperature will be adjusted accordingly. Uh, and that's pretty much it. So next tab is just a summary of all the information and the results. So you can print this out or save as a PDF.